Hello dear students, so now today we would move ahead in this first chapter of class 11th mathematics, that is sets. So today we have some new sort of questions here. So the question is which of the following are examples of singleton set? Singleton set means a set having only one element there, okay, would be called as the singleton set. Okay, so let's see whether this one given set is singleton set or not. You have a set which contains the element x such that x belongs to the set of integers, and one more condition has been given here such that x square should be equals to 4. So you have many integers. You have integers are what? X belongs to the set of integers. So x could be what? 0, 1, 2, etc. Then -1, -2, etc. So many elements could be there in the set A, isn't it? But only those elements would be there in the set. Only those integers would be there in this set whose square is 4. So how many integers are there whose square is 4? You have two integers. First one is 2 and then you have -2. Look here. If x is 2, x square is 4. And if x is -2, it implies x square is again 4, because the square of -2 is also 4. So here you have two elements, isn't it? This set contains two elements, 2 and -2. Rest of the element would not be there because it cannot contain 0, because square of 0 is not 4. Square of 1 is also not 4. Okay, so other element would not be there in this set. So you have two elements there, 2 and -2. So is it a singleton set? No, because it contains two elements. Hence, let's say this is set A. Hence, set A contains the element 2, -2. So is this a singleton set? No. Hence, set A is not a singleton set, isn't it? Okay, just note it down. Then we would move towards the next question. Okay, and this is the next question. Question is, you have a set A. Let's say it is set B. And this set B contains the element x such that x belongs to the set of integers. Integers are 0, 1, 2, 3, 4, then -1 also, -2, -3, etc. So these are our integers. Okay, and one condition has been given here: x plus 5 should be equals to 0. So what are the integers in this set? Integers are many, but only those integers you have to take. If you are taking the value of x, if you are adding there 5, the answer would be how much? 0. So there are many integers, 1, 2, 3, etc. Then you have -1, -2, -3, -4, -5, etc. So what are the possible elements in the set A? If x, let's say x is 0. So 0 plus 5 is 0? No. So 0 is not an element here. 1 cannot also be. Means the positive elements cannot be here. Let's move towards the negative. Let's say x is -1. So if it is -1, so -1 plus 5, not 0. -3 also cannot be there. -4 also cannot be there. If x is -5, let's say x is -5. So we can write x is -5. So -5 plus 5 is equals to 0. So -5 is the element here. And rest of the elements, -6 also cannot be an element here, because -6 plus 5 would not be 0, equals to 0. So hence it contains only one element. Hence set B contains only one element, that is what? -5. So which is the example of a singleton set. Hence set B is a singleton set, isn't it? Note it down. Now you have the next set here. Let's say this is the set C, and this set C contains the element x such that x belongs to the set of integers again, and condition has been given: modulus of x should be equals to 1. Modulus of x means x can be -1 also, can be +1 also, because -1 modulus is also positive. So let's say I am writing mod of -2, so answer would be 2. Mod of 2 is also would be 2, isn't it? Yes, any integer if you are taking inside the modulus, so answer would be +1. Okay, so now just tell me what are the possible integers you can take here whose modulus should be equals to 1. So let's say if x, integers are many, 1, 2, 3, 4, 0, and then -1, -2, etc. Okay, so I would start from 0. If x is 0, so modulus of 0 is 1? No, cannot be. If x is 1, it implies modulus of x is also 1. Yes, modulus of x is 1, modulus of 1 is 1. It implies what? It implies 1 is the element here in this set A, because modulus of 1 is 1. Okay. Now if you cannot take 2 because modulus of 2 is 2, so 2 is not the element here. Okay. Now move towards -1. Let's say x is -1. So modulus of -1, yes, it will also be +1. So it implies what? This set contains 2 elements, +1 and -1. So is it the example of singleton set? No, because it contains 2 elements. Hence C contains 2 elements. What? -1 and +1. Isn't it? So is this a singleton set? No. Hence C is not a singleton set that you would write here. Okay. Just note it down. Now here you have the next set. Let's say this is the set D, and this contains the element x such that x belongs to the set of natural numbers. Natural numbers are what? 1, 2, 3, 4, etc. Only these are the natural numbers. Okay. And one more condition has been given: x square should be equals to 16. So what are the possible elements here? Can it contain 1? No, because the square of 1 is not 16. It cannot contain 2 also. It can have only the element that is 4, because the square of 4 is 16. So hence the set D contains only one element, that is 4, isn't it? Rest of the elements would not be there. You cannot take the negative one because x is natural number. So natural numbers are only the positive one. Okay. So hence the set D contains only one element, that is 4, because the square of 4 is 16, and the rest of the elements would not be here. Isn't it? Yes. So I would write here, hence D is a singleton set. Here you have one more example of the singleton set. Okay, note it down. Now this is the next question, that you have a set E that contains the element x such that x is an even prime number. So prime numbers means which are divisible by itself. Okay. So but you have to check even prime number. So even prime number means even number is 2. So is it a prime number? Yes, 2 is the only even prime number that you might be knowing. 2 is the only prime number which is even, and the rest of the prime numbers are odd. Isn't it? Yes. So 2 is the only even prime number. So the set E would contain only one element, that is 2 here, because the rest of the elements, because only 2 is the even prime number, because you are not having any even prime number after 2. Okay. 3, if you take 3 is odd prime number. Let's take 5 is also odd prime number. So rest of the prime numbers are odd, but only 2 is the number which is even as well as prime. So this set contains only one element. So hence E is a singleton set. E is a singleton set. Okay. Okay, that is all for today. Would be discussing some more questions of this chapter. Till then, stay tuned and keep watching. Thank you. Have a good day.